And here we go. Live from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about nobody winning the moon. And if I have time, what's going on with the expansion of the universe? And of course, taking listener questions about all things all things, because this show is about the entire universe. We record the show every Thursday at 4 p.m. Eastern, so call 888-581-0708 to join the conversation. And in today's Blue Shift, I'll be talking about how to kill Pluto and why it may have had it coming. But first, the news. Hello, space fans. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State, chief scientist at COSI, and for the next half hour, your agent of the stars. We've got an exciting show for you today on Space Radio where we talk about all things space, astronomy, astrophysics, rocketry. If it's above the Earth's atmosphere, it's in this show's universe. This show lives on listener questions. We record every Thursday at 4 p.m. Eastern here in Studio A of WCBE Radio Columbus. So call 888-581-0708. Light it up. Get those calls in. We'll have a nice little chat. You can also follow along on our live streams on YouTube, Facebook, and Twitch. Check out spaceradioshow.com for the links. You can also follow me directly on social media. My handle on all platforms is at Paul Matt Sutter. Seriously, folks, I've only prepped 10 minutes of show material tops, so get those calls in. Before I start taking calls, though, I wanted to share some interesting bits of news that I caught recently, and this has to do with the Google Lunar X Prize. You may have heard of Google offering these breakthrough prizes that if you can do some amazing feat of engineering and technology, they'll give you a big wad of cash. Maybe one of those giant checks, that they pass out at the ceremony. I've always wanted to get one of those, even if it's for $1. I just want a giant cardboard check. But anyway, 10 years ago in 2007, Google announced the Lunar X Prize, which was if you can design, build, launch a spacecraft, send that spacecraft to the moon, and then have that spacecraft perform a soft landing on the surface, which means no crashing involved, and then send a little rover to scoot around the surface, Google will give you $30 million. $30 million, that's a lot of money. That's a lot less money than one of these missions would actually cost. But hey, it might pay for some snacks. It might pay for, a couple dinners out over the course of a decade. It will pay for, it's a good chunk of the budget. It's not 100%, but it is definitely a good chunk. Now, it's been 10 years, and the original deadline was 2014, and they extended it by a year, and then another year. And then another year. And then finally, this past year, they said the winner is absolutely nobody. Absolutely nobody. Nobody won. Nobody won. Nobody got the X Prize. Nobody was able to actually get all the pieces together. A lot of teams, there were 5 international teams, and some of them didn't get it out of the design phase. Some of them actually were able to test and put things together, but they couldn't afford the actual launch yet because, Google doesn't give you the $30 million until you're done. So you have to put a lot of money up front. And what does this mean? I think this raises a really interesting issue about what does it mean when someone is willing to lay out $30 million and no one was able to do it. No one was able to actually accomplish a purely robotic moon mission, which is far, far simpler than a crewed moon mission. And does it mean it's basically impossible to go to the moon, that we're never going to go back? Does it mean that that private enterprise really doesn't have the capital or the manpower or the expertise to design a lunar mission? Or does it mean that just, $30 million wasn't enough incentive, that these small groups, even though they made a big advertising splash and a lot of news, really didn't have their stuff together to make this actually happen? It's just such an interesting question. I don't think it spells the end of space exploration, especially private space exploration, but it does place some pretty interesting constraints. It gives us a window into this world that space is hard. That going to space is one of the most difficult things you can do, perhaps second only to asking someone out on a first date. Right below that are missions to outer space, and especially trying to land things on another object, like the moon, like Mars, doing robotic missions. This is incredibly hard. Progress is going to be slow. I think that is the ultimate lesson from this. Progress in space is going to be slow because it's a very, very hard thing to do. That's the latest and greatest when it comes to space, but it's time, I think, to have a conversation. We've got a caller. Hey, Randy, thanks for calling Space Radio. Where on earth are you? All right, Sarasota, Florida. Randy, have you called before? All right. Welcome back, Randy. So good to have you on the show again. What are you curious about today? Hmm. Oh, that is such a good question, Randy. I think there's so many aspects to this discussion about one side is if you had an infinitely powerful computer, what would you do? What could you learn? And the other is what are some interesting kinds of problems that you can solve with this special kind of computer called quantum computers? And the good news is quantum computers already exist. They're already there. They're already a thing, but they're very, very small. Just a few bits, like a dozen. I think the most is like 32 bits right now that can actually be used in this very strange quantum cohered state. Uh, I don't really have the time to dig into what is a quantum computer and all the amazing physics behind quantum computing, which I mean, that's a whole other show. That'd be a great topic for the podcast to really dig in. So I'll add it to the list there. Quantum computers are potentially able to solve some very, very challenging problems, like you mentioned, that traditional computers struggle with. And they can do this in a highly, highly parallelizable way where they can solve many problems simultaneously and then arrive at the correct solution. And there are a few specially designed quantum algorithms that are specifically designed to solve some very vexing problems there in traditional computing. I think going beyond your question, or I think the spirit of your question, Randy, is what if we had computers that were 100 times more powerful, 1,000 times more powerful, a million times more powerful than the computers we have right now? What are some of the interesting problems that we can solve? And this brings up a very interesting issue in my particular research area, which is cosmology, dark energy, the growth and evolution and structure of the universe. And something that we run into a lot in physics, in astronomy, is that it's not so much when you're doing some data analysis, you're doing some study, it's not so much the answer, like the particular value, like how much dark energy is there in the universe. Like there's some answer out there and we can work to discover that answer. What really matters in terms of trying to understand how our universe works is the uncertainty around that answer. You know, an answer of 1 plus or minus 1 isn't a very useful answer. It doesn't tell us a lot. An answer of zero point 0.5 plus or minus 0.01 is a very useful answer. Having a very tight uncertainty, having small uncertainty, being very precise in our measurements is much, much more useful than whatever the actual value is when it comes to observing our universe. And this is where we run into a lot of computational headaches because the data analysis and the theoretical analysis are so computationally demanding, especially if we want to do statistics right. If you want to be lazy about statistics, which most scientists, to be honest, including me sometimes, are lazy about statistics. They just kind of fudge it and hope it works out for the best. If you want to be rigorous about statistics, if you want to do the right thing and actually get a good handle on how certain you are of that answer, that requires immense computational power. And this is something I think we're going to see start changing over the next couple decades, is as computers get more powerful, we will get better computational understanding of the universe around us. Excellent question, Randy. We're going to take a quick break. Don't forget to call 888-581-0708 to join the conversation or catch the live streams on YouTube, Facebook, and Twitch. Visit spaceradioshow.com for all the links or follow me directly on social media. My handle is @PaulMattSutter. I am Paul Sutter. This is Space Radio, and this show is brought to you by you. Visit patreon.com/PMSutter. Especially Randy R., our top contributor for the month. Learn how you can support this show. That's patreon.com/PMSutter. See you after the break. All right, live streamers, now that I'm out of the segment, I hear you loud and clear that you cannot hear the callers. Can you guys still hear me? Is my voice still coming through all right? I want to make sure it was just the caller that you were missing, which is so strange. Because sorry, quick diagnosis break on our gear. So it's very strange. I'm talking to Greg right now, guys, by the way. If you're catching this later, just jump ahead a couple minutes. I have a little mixer here, or not a mixer, a little level thing. And I saw, Randy's levels move in just fine. So I don't think it's you, Greg. I think it's this stinking software. But when Melanie calling in, when we did our test before the show opened...
Could the live streamers hear it then?
No, the live streamers hear me just fine. Mm-hmm. But they couldn't hear the caller. So... Oh, look. Yeah,
should be getting a level, right?
Yeah, but... So there's a microphone built into the laptop. It's a USB audio device. That is weird. Well, we don't have any more callers today.
Right.
So sorry, live streamers and video people. I check this every time. I do not sound like an angel. We check this every time before the show goes on. Sorry about the technical issues, and we'll keep a watch out for it next time. I think it's pulling the audio from the laptop, from the built-in microphone. I don't think it's pulling from, because see, when I tap, yeah, that should be a lot louder.
Right. It's in the mix.
That's weird, but I'm setting, I can set default. I thought it worked. This script makes for... Oh well, we'll just keep going. We'll keep rolling.
Okay.
Hey guys. All right. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. We've got another listener question ready to go, this time from the live stream. But remember, you can join the conversation by calling 888-581-0708 or by following the live streams. Check out spaceradioshow.com for all the links. So on the live stream, there were two questions that popped up that I wanted to address. We have SAHM asking about rotating black holes and if every black hole has to be rotating. we know like lots of stuff in the universe rotates, right? Earth rotates, orbits around the sun. Sun itself is spinning. We're rotating around the center of the Milky Way galaxy. Milky Way galaxy itself is not rotating, it's just moving in a straight line. So not everything in the universe rotates, but there's a lot of spinning action, especially when you get down to small stuff. So when you start talking about black holes, is it possible for for a black hole to be absolutely still, to be perfectly motionless, to not be spinning at all? This is the default solution, the simplest solution when you go to try to explore black holes. The simplest possible black hole you can construct mathematically is an uncharged, unrotating black hole. That said, so obviously, black holes can not rotate in principle. It's perfectly legal, according to the rules of the universe, to have black holes that don't spin around. But we think, in fact, we're pretty sure, we will never ever actually see a black hole that's not spinning. Even though it's not forbidden, the mechanisms that generate black holes in your universe are always from spinning things. Black holes come from, they are the remnants of dead stars. They're what happens when the most massive stars in our universe die. And so stars are always going to be spinning. They are rotating objects. And as they collapse into a black hole, they're going to compress even more. So even if the star was just rotating just a tiny, tiny, tiny bit, like 1 inch a year, imagine the slowest, laziest star you can imagine. If it collapses into a black hole, there's conservation of angular momentum, just like a figure skater pulling in their arms, and as they pull their arms in, their mass gets closer and closer to their center, they're going to spin faster and faster. That is conservation of angular momentum at work. This applies to figure skaters. This applies to dying stars and black holes. Isn't physics wonderful? If you have a star, even if it's rotating just a tiny bit, a little random rotation, as it collapses, as it gets smaller, all that mass is getting crammed into a smaller and smaller volume. That rotation will get amplified. And the black hole will end up spinning considerably, even if the star that birthed it was hardly spinning at all. But this thing that birthed it, the star, is going to already be spinning rapidly because of the exact same physics. So as it collapses into a black hole, it's going to be spinning like crazy. So we expect every black hole in our universe to be spinning like nuts. And even though a non-rotating black hole is allowed in principle, we are only going to see spinning ones in our universe because of the way that black holes are formed in our universe. Excellent question, SAHM, on the YouTube live stream. Remember, you can call 888-581-0708 to join the conversation, to talk to me with your actual voice. If that's not your style, that's cool. Go ahead and jump on those live streams on YouTube, Facebook, and Twitch. You can find the links all at spaceradioshow.com. And there's another question that popped up in the chat that caught my eye, and this is from Cerilio. Cerilio asked, would it be bad for us if we discovered extraterrestrial life? Like, what does that mean? Let's say the day happened tomorrow. The SETI instruments that search for extraterrestrial life, it pings, like bing, hello. And we get a message from the great void, from a distant star. What does this mean? Is this a good thing? Is this a bad thing? Is it somewhere in between? Is it something we should be worried about? I know some prominent scientists whose names might or might not rhyme with Schmeev and Schmocking have said it would be horrible if we were to make contact with aliens because, I don't know, they want all our gold or all our water, or they want to hear all of our traditional folk music. I don't know. Like, for some vague reason that I feel, and this is my personal opinion, but hey, this is my show, so it gets to be about my personal opinion. It's not really well defined why we should be afraid of aliens if we discover them. I guess there's this feeling that they might want something out of us that would do us harm, but we have to remember, that first things first, our galaxy is so ridiculously gigantic that we as humans have incredible difficulty visualizing it. And I'm going to go out on a limb here. I'm going to say that's impossible to truly visualize the immense scales of interstellar distances. We already have trouble visualizing like how wide the state or country you live in is, or the fact that it takes hours upon hours to transit the Atlantic Ocean on a flight, how ridiculously fast we have to go in order to make that possible. We think of stars as like traveling around the world, like, oh, if we just had a fast spacecraft, it would just take us a few hours to get to Proxima Centauri. Ladies and gentlemen, even Proxima Centauri, our nearest neighbor, is so far away that even if you're going a tenth the speed of light, which is like 10,000, 100,000 times faster than our fastest possible spacecraft, even if you're going a tenth the speed of light, it's still 40 years to get to Proxima Centauri. 40 years. Imagine, if the European explorers, were departing, if Magellan's voyage lasted a century. It's just, if we detect aliens, the aliens are going to be so far away that one, communication is almost guaranteed to be impossible because just the delays and the power requirements. We might see evidence for life out there, and in fact that's exactly what we're hunting for, is evidence for life outside the solar system and off the Earth. Communication with them, assuming that we're at the same technological level and we can actually understand each other, which is like so far beyond the realm of possibility. I mean, it's technically there down in the math as a tiny random chance that there's another intelligent species close enough to us in the galaxy that we can actually start communicating. Even if that were the case, just odds are in our favor. They are so physically far away from us that there's nothing we can do. We can't send stuff. We can't send, Amazon Prime over to him, send him a gift wrap package, a fruit basket. That's just not a thing in interstellar distances. And I know I come off as a pessimistic in these kinds of scenarios, but it's just looking at the numbers, at the scales involved. And I really think it's our human bias here. It's our human bias of our earthbound existence that prevent us from thinking about and imagining the truly vast interstellar scales. So if we were to somehow communicate with aliens, make contact with extraterrestrial, they're not coming here and we're not going there. We pen pals with like 100-year delay between messages is the best we can hope for. So I am not afraid. I am not afraid of aliens because they're really, really far away and we have nothing to offer them. Any element that's on the Earth is already all over space, like crazy. Because the Earth is just made of space stuff, just concentrated in one point. So we got nothing. So it's just going to be pen pals. We're just going to have a lovely little chat. And that's nothing to be afraid of. Thank you, live streamers, for all those amazing questions. We're almost out of time today on Space Radio. But before we go, it's time for the Blue Shift. 100-year delay pen pals. That's exactly right. I'm Paul Sutter, and you're listening to Space Radio. And this is the Blue Shift, my opportunity to get a little bit closer to you. And I have two announcements for us today. One is if you happen to live in the city or near the city of Columbus. And then the other is if you don't. Actually, the other applies no matter where you live. You may be familiar with the saga of Pluto, of whether Pluto is a planet. One of the people, the astronomers who led the charge to demote Pluto and assign it in the new category that we call dwarf planets, is an astronomer at Caltech named Mike Brown. Fantastic astronomer. I personally disagree with the designation, but I'm not a planetary scientist. I'm a cosmologist, so, it's not like I have a lot of legs to stand on. When it comes to that argument, it doesn't stop me from having an opinion, but, there we are. Anyway, Mike Brown, he's still a fascinating guy, still an excellent, excellent astronomer. He also thinks there's a new Planet 9, a massive object about the size of Neptune, somewhere way out there in the solar system, like 50 or 100 times further than the Earth. Really, really far out in the, or 50 times further than Pluto, like really far out there. He's coming to Columbus, Wednesday, March 7th, public talk. There is going to be an absolutely free event. Location to be determined. It's either going to be hosted at COSI Science Center, pending availability, or it might be on campus. It might be another venue in town. He's got a new book out that's really fun. Mike Brown, the guy who killed Pluto, and the guy who explains why it had it coming, is coming to Columbus Wednesday, March 7th. So that's if you happen to live in or near Columbus. Come see that talk. Go to ccap.osu, ccapp.osu.edu for more info. For everyone else in the world who doesn't get to see Mike Brown live, I'll be there, of course, is next week. It's going to be a very special edition of Space Radio. I will not be in WCBE Studio A here in Columbus. I will be leading our inaugural Astro Tour on an aurora hunting expedition in sunny and pleasant Iceland. That's what they said on the brochure, so I'm really excited by it. And we're going to try to do space radio from Iceland, featuring questions, live stream if we can get the live stream going. There's 43 of my closest friends coming with me on this adventure. I'm going to take their questions. We're going to record it. It's going to be a hilarious mess trying to get that going because I won't have my Greg with me. I'll be recording by myself, so who knows what will come out of my mouth and end up in the recorded file. But it's going to be such a fun trip. I'm going to be live streaming online all the time. The whole time I'm on that trip, I'm going to be doing clips on social media, so follow along at Paul Matt Sutter on all my channels to keep up with me and all the adventures. We're going to record a bunch of stuff to post later. It's going to be a really, really fun. It's going to be a fun trip, so I'm looking forward to it. Most of you don't get to go. But that's all right. You can be with us in spirit. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. Once again, I'm Paul Sutter, and this show is brought to you by the Ohio State University Department of Astronomy. Learn more at astronomy.osu.edu. This show is also brought to you by you. Visit patreon.com/pmsutter to learn how you can contribute. Thanks to Greg Mobius for producing, Dan Michalko for being awesome, and all the fine crew here at WCBE Radio for making this show possible. We record every Thursday at 4 p.m. Eastern. Call 888-581-0708 to join me on the air. Also, catch the live streams on Facebook, YouTube, and Twitch. Follow me on social media at Paul Matt Sutter. Visit spaceradioshow.com for all the links. And of course, thanks again, Earthlings, for listening. See you next week. And remember, science is for sharing. End of transmission. Sorry again, live streamers, about the lack of caller audio. We'll get on that. We'll have our people get on that. The people being me means I got some tweaking. I got some playing around. I think I know what happens. I think I know what I do wrong to where the audio gets pulled, where it doesn't see this microphone and the input and the mix and everything. You're doing this show with us. We are all learning together about making space. We are assembling this aircraft as it flies. Thank you so much for your feedback on the chats. I think you should answer more questions. I agree. I've got 30 minutes. We are working towards a longer show format so that we can get more science in and more questions. And yes, Jonathan, we will get caller audio. What do I need to call the show? What's today's title for the episode? I'll let you guys ruminate on that while we pack up the studio.
You have a fan/visitor to the station.
I have a fan/visitor to the station.
Yeah, he was in the mixing room.
Oh, the guy that was floating around?
Checking it out. So before you leave,
Say hi.
Introduce you?
Yeah, I'll be out 5 minutes.
No, take your time. I think he just started a meeting with you.
Oh, okay.
We'll go bust in on it.
We should start charging. A live audience. $10 and you can go to the studio.
Hey, with that in mind, when we go to our new, we want to move our facilities at some point to the building across the yard. And there's so much more room there. And this Studio A, we will be able to accommodate.
Like make it
listeners.
a studio.
Yeah.
Like it could be split. Like Rita's show is on one side, mine is on the other.
We could do that, but we're thinking more for members, listeners. Bring them in for a donation to the station. They watch a studio every form, or they watch.
Yep.
Or there's a live audience for Space Radio. What do you think about that?
I like that. I would love a live.
That's audience. A little bit. That's down the road a little bit.
But we should charge. Get some bucks. And then 50% goes to me.
We're public. Whatever. We're public radio.
Whatever.
We need some cash.
Okay, 90% goes to me.
No.
Oh, I see. Now it's an issue. Now it's an issue about what the split
90%. You're rolling in cash like you need it.
Scott, thanks for seeing me on TV. Quantum space computers. I like quantum space computers. That's a very, and it ties in. I like titling it based off the caller and the live stream questions. Cheesy amount. I can't do a cheesy joke every single episode, even though I would love to. The mystery of caller's question. Yeah, who knows what the caller asked? You guys don't. If you want to hear like the more produced and professional with like bumper music and it's all really nice, go to spaceradioshow.com and there's the podcast version where it's fully produced. All these bits are edited out. You get to hear the callers and it's really fun. I like quantum space computers. I think that's going to be it. All right, guys. Thank you so much for watching. I'm going to try to see you next week from Iceland. No guarantee because it depends on local internet availability and connection. So we're going to go for it. We're going to try. If I don't see you live next week in Iceland, I'll see you live 2 weeks back here in Columbus. Take it easy.